Now, let the conversation flow as it comes up naturally. However, from my side, I'm really interested in comparing how these things are developing in Europe with how they are developing in the United States. So I have no idea whether, say for you, Rob, what you just heard sounds familiar, makes any sense, or is rather news from the moon, if you compare it with how these things are going in the US?
So I'll just say that my main US experience is with the Pittsburgh Supercomputing Center, where I think that many of the developments that Sunset has described are quite comparable. So there, the newest piece of hardware is no longer one piece of hardware anymore, right? But the Bridges device is about a $10 million new facility with, as he's described, with tens of thousands of cores, but only really on the order of something on the order of 1,000 boxes. But that's all integrated and with all the facilities here. So I think it's a quite parallel experience, at least, with the Pittsburgh Supercomputing Center to the one that's in Italy, I think.
Yes, I have to say that Michael Levine, it's a nice friend of mine, and so we are sharing quite often, more with the center funded by the National Science Foundation rather than the center funded by the Department of Energy. So we have some interaction with, I don't want to say Oak Ridge or the other lab, but there may be more relationship with the National Science Foundation centers as a piece, as you mentioned. Yeah.
So, Madhav again. Maybe I'll take a more a different view just to stir up this hornet's nest. My feeling is that the supercomputing centers in US are being challenged right now, and that the traditional way of computing that we have all come to see, where we have lots of these supercomputing centers, are facing challenges, partly because of funding, partly because of manpower, and partly because of the way they have been used, or at least people want to use. And I'll give you just a couple of examples, and I want to see how you folks feel things are happening in Europe. So, and I'm doing this sort of online, so forgive my real-time thinking as well as talking. First, I think that the way of assigning cycles to individual users in US is being challenged in a big way. We're so used to saying, okay, I'm going to apply for 20 minutes, 2 hours, 5 days, whatever number of cycles I need, and waiting in the queue is simply not acceptable by scientists. People still end up doing it, but that's not how science wants to proceed. And so people are looking for alternative models. So clouds at Amazon provide some form of relief in that, but the problem with clouds is that they're really not at a stage where you can give a large number of cores simultaneously to the users, as you know. And I'm speaking all of this from a computer scientist viewpoint. I'm trained as a computer scientist, and I've been working in this for a while. So the first challenge is that access to these machines is not straightforward at all. Second is that even if you give access to these machines, there are only very few people who can really go into the nuts and bolts of these machines to use them. And this is another challenge that we are facing. So, of course, in US, there's a big push for exascale computing, much like you folks have here. But programming models, making the systems robust, are all being challenged again. So this is something that we need to figure out. And in some ways, what's happening is just a few people have access to this. So on one hand, we have talking about democracy in this, but the challenge is that the tools are available only to very few. So this is not how science would have liked to proceed in a certain sense. And the third thing is that the supercomputers, as we have defined, are so devoid from the other direction of scientific revolution, which is I'll use the word, but it's IoTs where you have lots of small devices being spread around. To me, they're also part of supercomputing. So there is one big machine, and I'll say a little bit about it in my talk too. How do you reconcile all of this seems to be a challenge as well. So I say this to take a complementary view and see and hear what European side would have to say and how they're trying to proceed with this. But I think we are really facing some very interesting challenges in US right now.
I want to ask Chris, because you know the European scene quite well. To what extent do you think the whole dynamics of supercomputing and what's related to it, including big data and stuff, is similar in the EU and America? And to what extent do you think it's really different?
Well, I don't know if it's because we work together, but there's going to be an element of repeating some of the things that Madhav said, which is actually related to my first comment. But let me answer your question in this way. I think if you go to a high-performance computing conference, you'll see on the one hand a lot of scalable modeling sorts of projects that are impressive and interesting. And on the other hand, you'll see a bunch of guys giving presentations where the slides are, of a VI screen with algorithms in them and talking about this stuff. In software generally, the way automation is affecting software and just the creation of volumes of software isn't so much, I think, maybe what we expected with computers programming themselves and stuff, although there's an element to that. What it is increasing abstraction in languages so that the programmers are much more powerful, so that the programmers say less, do more, and connect to a lot of things. So the similarities, I think, are as follows against that backdrop. High-performance computing has not followed the path of the kind of advances in software that you see in other areas of software development with extreme levels of increasing abstraction in programming environments that cause really a lot of productivity changes which lead to more and more use and so on. This is not happening on either side of the Atlantic in any kind of meaningful way in high-performance computing. And people still want to know if you're an MPI, if your latest application is, MPI 4.5 or not, in the middle of the, and this is an important question, but it's also in the weeds with respect to this idea that high-performance computing is actually going to impact in a big way things that require so much work, 1 million lines of Fortran code or whatever he's talking about on this model almost certainly is a level of effort that requires in the future, these kinds of things, if we're going to have lots of those things and they're interacting, we're going to have enhanced programming environments, and this isn't going to happen in an environment that's sort of a hacking style environment, okay? So that's the first thing I think that is very similar, is that the characteristic of the development environments and the way the machines are built and utilized and allocated to riff on what Madhav was talking about is all in a fairly old-fashioned view of computing systems. So I think this is similar, and I think it's an impediment to the utility of using high-performance computing, and I think it is, it's not negative in some respects, but I think it's indicative of this. When you talk about clouds, allocation of large number, okay, what you're really talking about is interprocessor communication being the obstruction. In the kind of calculations in social calculations that are memory-centric, there's a lot of communication, and there's a lot of need for being able to read and write very rapidly out of memory. Cloud applications aren't necessarily very good for these kinds of unstructured graph style, very large numbers of processor calculations. However, if you start taking parallelism as what HPC is about, massive amounts of parallelism, then we can really sort of tap into pervasive computing the notion that we're all walking around with computers, we're all sensors, we're all, and all that stuff. And you take the backplane wherever it is, and then you have these things called fogs and mists and other kinds of more and more pervasive things, and you tie those things together, then we still need these facilities. Then they have to be service-oriented facilities rather than batch-oriented facilities. They need to be responsive to all different kinds of coders, you know, coming in from it. You're going to need increasingly abstract languages. So I think the future that guide, because there's this one similarity, I think the futures that guide them forward are different. So if you look at the implications, say, in an automobile manufacturer uses HPC to help design gear trains or flow, you know, wind flows or something. These are traditional applications. They're very much like the ones we used to see at Los Alamos. They're very much like actually atmospheric calculations in some respects. And those kinds of things can continue to work, I guess, in the same sort of environment we are. But if you're going to move into socially coupled systems, then you have to actually couple with social systems. And right now, I would say that whether it's the anything other than just, you know, high-speed machine learning in parallel against big databases, anything other than that, I don't really think that the HPC environment is particularly well suited currently, and I think the vector out of it needs to be changed on both sides of the Atlantic. Having said that, I will say this. In the United States, all the universities that are sort of trying to do an upward trajectory rapidly are focusing on a pathway via one form or another, compute intensive, usually high performance computing intensive, things that are not at the scale of a national high performance computing center. They're very capable, local, well-defined things, and they're happening in universities. So the movement, you know, we still have NCSA, we still have San Diego, we still have Buffalo, we still have these places, but the movement is to make HPC more ubiquitous, somewhat more tractable, more involved locally and tied to the futures of these institutions. And I think that is a little different than maybe what I see happening with the computing centers in the European plan.
So I'll follow up on that, Chris, and just say that, and maybe with regard to Madhav's comments too, is that having spent a lot of time in my youth working on chemical kinetics calculations in large-scale Cray environments, and then wanting to do social science stuff, for me, there was a big desert from the 90s to the 2000s when supercomputing was not that useful to me. But it's precisely now, because of the change of the orientation away from vector machines and away from kind of synchronous communication into things that are asynchronous with large flat memory spaces, that means that I can do more now than I could ever do before. So I had no use for a supercomputing center before, because they were all vector machines, for example. But now, precisely because the architecture is relaxed, I can do a lot more there. So, for example, Nick is the guys at Pittsburgh have been very helpful to our research program in terms of trying to stimulate 120 million agent economies. Having said that, though, I'll agree with Chris that, but it's maybe in a different way, and say that it seems to me that when it comes to doing large-scale social computations for policy or for just pure social science, for economics, say, for financial crises, for networks, the big problem is that we do not today have very satisfactory parallel frameworks. That is, the whole POSIX, the whole kind of p-thread, microscopic kind of threading requires so much programmer interaction, and it's kind of unverifiable whether it's working right or not, that there's no way to leverage the productivity gains that we see in other parts of computer science by doing that kind of stuff. And then the whole paradigm of kind of OpenMP, MPI, Intel threaded building blocks, all that kind of stuff seems to be kind of only marginally better than having to deal with the thread level stuff of p-threads. So it seems to me, now we're way down in the weeds here, but it seems to me that what we need is a completely new paradigm for doing parallel computing. One where, in particular, to get at what Chris said about interactions, that we need to have a way, for example, to do the following rough, and I'm going to say that we need to do computing the way the social processes are done. For example, when when Chris Barrett woke up today, he was on his own thread, and he somehow inserted his thread onto the IMT thread to be part of this conversation today. Now, we don't have the idea of, in computing of having some, there are two completely separate thread execution streams that can kind of join for a while and kind of come apart for a while without producing terrible data race conditions, for example. So there are social institutions associated with the way we live our lives, associated with having global clocks. Not having a global clock, but having a local clock. We will all agree to start lunch at 12:30 in this room, but people outside the room are not going to do that. We don't have schemes to parallelize computing in a way that would be suitable for social science, for policy. That it seems to me that so it may be the case that it turns out I'm teaching this semester. I'm teaching parallel computing for agent-based modeling. So it's all fresh in my head right now that the whole paradigm of having interrupt-driven, now we're way down in the weeds, having interrupt-driven processes, and not being able to guarantee that certain compute processes have a certain timetable on which to execute. That's very problematical from the point of view of doing social science modeling. And so it seems to me anyway that to me it's very exciting though that I come from I did my graduate work at a university that took these issues seriously at Carnegie Mellon. There was always at that time a view that vector supercomputing would solve all problems. We know that's not true today. It seems to me that right now it'd be a very exciting time to be, for example, a programming language writer or even a compiler developer, because there's such a much more wide open set of possibilities than there were, say, when I was a graduate student 25 years ago. So the exciting thing is that you can do a lot more today than you could ever do before. The very problematical thing, though, is that we are to some extent locked onto the hardware scheme that we have, and that hardware scheme involves, the usual structure of, Intel style, von Neumann machine type things, but not going the multi-core route. I'm going to say it a different way now. I'm going to make the same point a different way and just say that when it comes to social science computing, when it comes to policy, it seems to me that the only way to actually leverage all the compute facilities we have today is to do some flavor of agent-based modeling / network analysis. That is, the old-fashioned schemes of doing econometrics, of doing computational stat. There's no easy ways to parallelize those computations, where there's a very natural way to parallelize things when you have large numbers of interacting agents, large numbers of interacting nodes in a network, say. But what we need to have are new paradigms to make that more efficient. Today we can do large-scale parallel social computation, but it's painful to do it. And in order to get our productivity up, we need to create better programming paradigms.
Just a few. So, generally speaking, I do agree with the analysis. Indeed, so all together we are trying to work very much in order to, let's say, mitigate some of the point that has been arisen. So that could be two different kind of approach. One is saying, look, so the current HPC computers would have an overall memory RAM available in the order of many petabytes. Okay, so in principle you can do everything in memory. Okay, so I think that I don't know to say. So the size of the memory that is available at Cineca, it's much beyond what it will be the kind of request that we do receive from the point of view of the, scientists in socials. Some of the examples that I made, but nevertheless, there is the point that has been arisen. So the idea is to working in a different way, and so there are two main critical points. One is go beyond the POSIX file systems. So the current way to manage the input-output, just to be very direct, doesn't work. Either towards a scaling somehow, okay, and it would not work with respect of all the, let's say, from the point of view of the traditional HPC guys, okay, emerging domains like social science, bioinformatics, humanities, and so on. Okay. The other point is the processing RAM, processing memory, that would receive a very strong, we do suppose, let's say, support and the new opportunities by means of the new NVRAM that would be coming less and less costing. Okay, and so from this point of view, there is, at least at the European level, I would like to share with some US friends what is going to happen in US. The, let's say, most reactive community is currently the community of the Human Brain Project. I don't know if you are aware about the Human Brain Project, which is a technological project, okay, in the domain of life science. So that community, that is a community that has to do with the numerical method, okay, but at the same time with data that it will come from, let's say, observation and experiment that has to do also with the clinics approach. So I mean, a situation that is really very much complex. Apart whatsoever, I would not again enter into the merit of the science and the scientific outcomes. Okay, so there's been a very strong debate between the neural sciences and so the physiologist and the computer scientist and the let's say physics. Okay, and so I wouldn't enter into that kind of merit, but there will be a very significant project that is a project that it will manage and it will move something in the order of 40 million euro for a procurement per innovation lead into the strategic grant agreement at the level of member states and the European Commission for a new infrastructures based on the approach that I tried to describe before. So go beyond the POSIX from the point of view of the input-output and introducing processing memory by means of NVRAM technology, in a few words, on a side of managing of a large volume of data in on a RAM. And that project will be carried on by 4 centers, Cineca, Jülich, CEA, and Barcelona Supercomputing Centers, that it would receive 10 million euro each for a PPI procurement, that it would provide, okay, so the driver is the strategic grant agreement for the Human Brain Project, but at the end that it will be a step ahead towards what it will be the evolution of the infrastructures, okay? And because there is this kind of overlap between, so the heads are always the same, okay? Between praise and the sites that it will be funded by means of the Human Brain Project, that it will become available at the price level from the point of view of the model, okay? And so that is the step forwards that it would try to mitigate, maybe not to solve, but mitigate the, let's say, constraint and the consideration that has been made, that we are recognizing that are becoming more and more important, especially with respect of, let's say, domain where the typical parallel programming approach does not work very much.
Virginia, take one. Virginia, take one. Go ahead.
You ask it for okay. So I think I want to challenge Rob a little bit, just because I think we are here for discussing this. So my feeling as a computer scientist is that while shared memory is a very useful paradigm, and you know, when I was a graduate student, PRAM algorithms actually were popular, and then they died a little bit because machines couldn't keep up with PRAM structures, but they've come back effectively with shared memory systems. I think if you're going to go to exascale systems, such as the one that are being envisioned right now, there are going to be all sorts of strange mix in it, right? There is neuromorphic computing, there are GPUs, there is shared memory systems. So, and if you want to scale beyond the numbers we are talking about, and also to the depths that you want to go in terms of decision making, then I think that's a challenge we'll have to face as computer scientists. And I think that, and I'm not saying I have a solution, but I think the way the machine roadmap is going, and I was at the national meeting for computing in US, it's not looking it's not looking in a direction that we would all like to. I mean, the physics codes at Los Alamos really drove the initial computing, but we need something different right now, as you're pointing out. So that's one point, that computing is getting more and more diverse, in fact, rather than going in one direction. So this diversity has to be taken care of. The codes are becoming more diverse too. That also needs to be taken care of. And I'll just close with a remark, which maybe I think, Rob, you had said, and Carlo, you talked about this 0.02 seconds in your decision-making frame to make this useful. I think you said this in your opening remarks. I think we're far away from it. But when I first started, when me and Chris used to pitch this project to DoD, we used to say that we want to provide a Google-like environment, where a search-like environment. You type something in and you get the results back, and you don't have to worry about how computing is done, which is something that I still subscribe to. But I want to take it one step further, and I said I want a Siri-like environment, actually, where decision-making is also done. Because search, at the end of the day, is a static process. There's data, and the Google search engine really just searching for all the available information, doing a syntactic pattern match, and providing you with information. I think decision makers require a smarter version of Siri, because you ask a question, really, and you're doing a computation that is predicated on the question you have asked, and you're going to reply it. And I don't think so there's no database that is going to be around. There's never going to be a single database that will do this. So the modeling will become a central portion of the story. And I think that's a challenge for all of us as computer scientists, to build a next generation of Siri for decision making, which I think we are far away from it. So.
Yeah, I think that I just want to reiterate something here. With the level of empowerment of individuals and the amount of, with local computing, pervasive computing, the character of what we even mean by the identification of decision makers that are enabled by ICT has changed. It's basically everybody. And these networks of everybody are doing the computing, which means that the data structures that we use are not things we collect and then compute big models on, but they're this endless resource of provisional knowledge that has to be redone all the time. So the way high-performance computing of the kind we're talking about is used coordinates these networks. But it isn't like we just collect data, put it aside, compute models, anything going forward. We still do it now. But I really think this is changing. The computing at the whatever the next to scale is this pervasive parallelism. And it's extremely data-centric, and the knowledge and the way we act on it is extremely provisional. It's more like just keeping track, it seems like to me. And so extracting knowledge, having theories, all this stuff will still happen, but I really do think that the extreme scale computing is not going to happen in a room alone anymore. It's going to happen, it's going to be coordinated by centers, but it's going to happen everywhere.
If I may, I would like to give my 10 cents. It seems to me that from a European point of view, there is basically at least two trajectories. The most likely one is just business as usual. And business as usual means we don't produce these things. We don't produce hardware for supercomputing and that sort of thing. we are good in software applications for HPC and this sort of stuff, so it's not like we are losing everywhere, just like we are very good in machine tools, and there's a variety of things where Europe is good, at tourism, whatever you like. But business as usual, in my opinion, means from a European side, we will not get our act together to produce hardware. We will keep being good in software. We'll build an exascale machine or two, lagging somewhat behind the Chinese and the Americans, and therefore following the paradigms that will be established there. And therefore, at the software side, exactly staying on the track of, let's say, the familiar paradigm. That's what I expect to happen, and I'm a bit sad about it. I don't think that's the way we should go, but, you know, we'll survive. It's not going to be the end of the world, but it would be kind of a pity. There's an alternative, and I want to say a few words about the alternative, and then that may help us for lunch. It is useful to start thinking about Airbus. Airbus is, as far as I can tell, the only really large-scale industrial European project that was a full success. There are only two aspects I want to emphasize. First, Boeing was out there. I'm not much of an expert, but I know a few things. With the Boeing 707 in those days, which was, let's say, the default plane. Airbus did not simply say, we built the same kind of plane and tried to be a bit cheaper or something like that. Airbus started with a design of a plane which was really new. Now, it's like nothing, but instead of having 3 engines, it had 2 engines, which made maintenance simpler. Instead of having 1 aisle, it had 2 aisles, which made the plane more comfortable and, more money per flight. It started using composite materials. Before Boeing was using composite materials, it was not like, you know, something entirely different. It was still a plane and a lot to be learned and perhaps copied from Boeing, but there was something like a new paradigm involved. That's the first thing. And the second thing is it was based on a real alliance between the French and the German. There's some military background to this. I don't want to go into it. But the fact that France and Germany got their act together was crucial. It would not have worked without this. The British were in it too, which was very helpful, but with or without Brexit, it was not essential in the same degree. French-German cooperation enabled to include Italians, Spaniards, smaller countries like the Netherlands and stuff. It was not one big Airbus company. It was a huge industrial ecosystem that developed. It worked, and it's still working. Now, I believe, and I actually published something about this, that Europe is still able to do operations of this kind. Money is not a problem. Money is floating around and nobody knows where to invest it. The first problem is really this French-German cooperation. There's some steps in this direction since Macron took the helm in France. We'll see what the ball is now in Berlin. We'll see whether Berlin is able to respond to this so that something really develops. There have been conversations explicitly about joining industrial forces. But that's the first thing without which, in my opinion, scenario A will happen. And the second, which I think is more important for us here, is this intellectual paradigm thing. There's this man in Edinburgh, the director of the supercomputing center there, Mark Parsons, with whom we talk a lot. He believes that exascale will mean a new mathematics of computing. I cannot really judge this, but listening to Mark makes a lot of sense to me. What is more important for me is what you say, going into architectures that make sense from a public policy and I'm not saying social science, I'm saying services perspective. We forget the world is no more about industry, it's about services. Not only banking, it's everything. It's education, it's medicine, it's whatever. So developing the kind of mathematics and the kind of designs that are needed, that's, let's say, the intellectual, scientific contribution. And there Europe is actually well placed. Europe has absolutely leading computer scientists at the theoretical levels, no doubt about that. Europe has a fantastic mathematical tradition, and interestingly, France is the place where this is strongest. So that could happen, and personally, I'm very much in favor of it happening. As a researcher, it's more the second half. I'm not really involved in these industrial things. I speak with some people involved in it, and I think it's important and interesting. But the question whether Europe will be able to develop these new paradigms mathematically, computationally, and from the user's perspective, I think is challenging. I don't expect China, Japan, Korea, any of these countries to be able to do that. I know China very well. It will take them decades to get the mindset to be creative in this dimension. They are creative in many dimensions, but this will take time. Same for Japan and Korea. America may, of course, do it. There's no doubt. You have done many of these things. Strangely, it's not so important now, but I think it's useful to mention Russia might do it. Russia has an amazing mathematical tradition. And that leads me to a question I would like to look into in the afternoon, which is the relation between this exascale thing, which is now bundling the efforts, and the artificial intelligence work. So something is happening in artificial intelligence. You know, it was one of these things like Brazil. It has a great future since 50 years. Yeah. But now it seems we are getting closer to the great future. There may be synergies between supercomputing, exascale, and what's happening with deep learning and AI in some very broad sense. I have little to say, I have only questions. I hope we can look into it a little bit this afternoon. But what I want to say is that it seems to me there is like a window of opportunity for Europe to take the lead in something, and not just to be a follower, which is fine. As I said at the beginning, we can live with that. But as a scholar, I'm more interested in the intellectual breakthrough strategy, if you like. And this I firmly not only believe, but I'm willing to argue, and I totally agree with you there, public policy will change. But if we try to change it by using ICT in this old paradigm, we are changing it for the worse, which means that public trust will be eroded. Because it means that large bureaucracies will have access to huge data sets and do things that the public will not understand. That's a very good recipe for disaster in a place like Europe. So I see these two alternatives. I'm not saying it's the only ones, but I'm interested in it. And we are part of this process, and I would like to think more about it. If it's fine with you guys, I suggest we think about this and other issues over lunch. But if somebody wants to speak up before lunch, we can. But hunger is winning. So, Sarah, we meet again at 2 or what? Okay.